Okay, this is the part 2 of the video on coordinate geometry. This is the part 2, and today we'll be talking on distance between 2 points. So what are you to know about distance between 2 points? You know, we have the y-axis and then we have the x-axis. So when 2 points on a graph, when 2 points are on a graph, we are asked to find the distance between them. How can we find the distance? That's all we have talked today. We are also talking about lines that are parallel to each other. I missed the previous video to do that in this. So let's go on. Assuming we have a point here on the graph and another point here, and we are to look for the distance between these 2 points. Firstly, the distance between these 2 points is a line joining the 2 points. Can you see? Yes, it's a line joining the 2 points. This is the x-axis, as I said, and this one is the y-axis. So, in the between these 2 points, when we know that this point on the x-axis, and we should call this x1, and this as well is another one on the x-axis, and we should call x2. Of course, this is also on the y-axis. Call this y1. This should be y2. So with all of this, you can actually make out a triangle, this line, and make this a triangle. Looking at a perfectly right angle triangle, and we know that from Pythagoras theorem, a man called Pythagoras brought out a theorem that the line is probably which is always the longest, and also called the hypotenuse, that is facing this 90-degree. The square of that line is equal to the square of the line at this side plus the square of the line at this side. Let's go into solving it so you won't get confused. So what is the line from, what's the distance from here to here? We know the distance from here to here should be x2 minus x1, since we know that from here to here is x2 and from here to here is x1. So definitely from here to this point should be x2 minus x1. Remember, we are looking for the distance between the 2 points. So if this is x2 minus x1, this should be the same thing applies here, y2 minus y1, since y2 is from here to here and y1 is from here to here. So from here to here, which is same thing as here to here, should be y2 minus y1. And with these parameters, we can solve for the distance between the points. As Pythagoras has said, he said the square of the hypotenuse is equal to the sum of the square of the adjacent sides, which are these two sides. So the square of this plus the square of this. So from this is square. From this, we can actually look for the distance now, where the distance is the square root of y2 minus y1 squared plus x2 minus x1 squared. Yes, this is the formula when solving the distance between 2 points on a straight line on a graph as well. So this is the formula solving distance between 2 points. When you have to solve between the distance when you have to solve the distance between this point and this point. This is a point on the graph, and this is another point on the graph. And when you are asked to solve between these 2 points, you go with this formula: y2 minus y1 squared, the square root of y2 minus y1 squared, plus x2 minus x1 squared. So let's go into questions. Okay, the question says, for the first one, let's call it A. It says find the distance between these 2 points, point 1, 7, 2, and the second point, 1 and 6. You should know that a point is made up of the x and the y axis simultaneously, where this is the x axis and this is on the y axis, and this makes a point, and also this makes a point. So we have to find the distance between these 2 points using the formula we got from the first explanation, where I said the distance s is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared, all of these in a square root. So using that, we should know that this is x1 and this is y1, this is x2 and this is y2. Have that in mind. So finding the distance s, this should be the square root of y2, that is 6, and y1, that is 2. So 6 minus 2 squared plus x2. x2 is 1, x1 is 7. So 1 minus 7 squared as well. So this inside the bracket would give us 4 squared plus negative 6 squared, and this is equal to 4 squared, that is 16, negative 6 squared, that is positive 36. So this is plus 36. So 16 plus 36, so that would be equal to the square root of 52. So that is the square root of 52. So this is approximately 7.22, just write units, since it does not have any parameters, it does not have any measurement, so you write units. So looking for the distance between 2 points is so easy, and you just need to use this formula to find the distance between 2 points, and that's all. So let's solve another one just to clear the air. The second one, that was red pen, I'm sorry. So the second one, it says 3 and negative 3 and negative 2, 5. So we have distance between these 2 points, and you know the formula: s equals to the square root of y2, that is 5, minus y1, that is negative 3. This should be in a bracket as well, and the square, plus x2. x2 is negative 2 minus x1 is 3, and this should be in a square, should be in a bracket. And so the distance should be equals to the square root of 5, negative times negative, that is positive. So 5 plus, that is 8. So this is 8 squared, then plus negative 2 minus 3, that's negative 5 squared. So this is equal to the square root of 64 plus 25, and that will give us what? The square root of 89, which is equals to 9.43 units. Mind you,